Hi, welcome to the first lab of eLab. Here I'll talk about the details of the experiment you're going to do, so pay attention. There are 5 experiments in this lab. The first experiment can be accomplished by 1 multimeter. The other experiments need 2 multimeters, so cooperate with your classmate next to you. Experiment 1 wants you to measure 1 ohm, 1 kilo ohm, and 1 million ohm. We require that your measurement error should be less than 10%. Note that when you're doing the second part of experiment 1, your measurement error could be much greater than 10%. This is expected because you're measuring with your hands. But what does it mean to measure with hands? It means that your hands should touch the resistor while you're measuring. Hold your resistor with your hands. This will make the resistor of your hand and body becomes parallel with the resistor you're measuring. Of course, this is a bad measuring method. Therefore, we use this experiment to illustrate this concept. In normal measurements, prevent your hand from touching the device gets you better measurements. Besides the method that is marked with an X, the others are all good to use. Experiment 2 wants you to measure the output of the power supply. If you have seen the material from previous semesters, note that we've changed some number. We select different number for the master and slave so that you could easily understand the difference of free modes. Series mode exists for us to generate large voltages, while the parallel mode is for larger current values. Write down your measurements and draw your connections in the figure. As for the last one, you have to measure absolute voltage of shown value. The measurement method is described in the next page. In order to measure an absolute voltage, we have to connect the ground with the circuit. Connect the ground with the negative of master and positive of the slave. Then we could get positive 5 by putting the black end of the multimeter on ground and the red end of the multimeter on positive on master. You can measure negative 5 voltage with similar method. Experiment 3 follows the pre-lab 3. Measure 3 different resistors. Note that when measuring 1 ohm resistor, because of the small resistance, we will use lower voltage and special resistor material that could withstand large current. You can recognize this resistor by its larger size. Also, 1 voltage is the limit of the resistor, so it may be very hot when in use. Please be careful so that you don't get hurt. Use the 2 circuit configuration to measure the size of your resistor and write down your measurements in the table. Note that the error could be very large because one configuration is better for measuring small resistance, the other is better for big resistance. Experiment 4 wants you to measure the voltage in these 4 configurations. The ground is the absolute voltage reference. Measuring these will give you the idea of the relationship between 3 endpoints. It is possible for your result to change continuously in the experiment. In that case, write down the range of your measurement. Experiment 5 wants you to build the cubic circuit on your breadboard. Note that since one person only has 6 1 kilo ohm resistors, then this experiment needs 2 people to cooperate. To build this cubic circuit, you could simplify the circuit. You would take a bird's eye view, look the cubic circuit from above. You could view it as the figure next to it. This makes the cubic circuit becomes a planar one. Then you could connect it on your breadboard. Now I'll talk about the concept of equivalent potential and how to use the equivalent potential to simplify your circuit. You can simplify via this method and calculate the resistance, which enables you to verify your measurement. When different points in a circuit is known to have equivalent potential, they could be viewed as the same point. Therefore, when we're measuring AC, we could see that B, D are symmetric, F, H are symmetric. Remember that symmetric points have equivalent potential. Now we know the circuit can be simplified into the right figure. The R/2 came from viewing the resistor between AB and AD being connected parallel. You could simplify the resistance between AD and AG with the same concept. There is also one bonus lab. In this lab, you could practice the other type of power supply in our laboratory. Basically, it's the same as the second lab. Only note that its ground is the green endpoint. After you've done each experiment, find your TA and demo to him. The TA will record the experiments that you've done the demo. Only those are considered to be done. So remember to demo every experiment to your TA. After you finish the whole lab, remember to clean your table and turn off all devices. Otherwise, you'll lose some points. Before the next class, also remember that you have to hand in the final reports for this lab and also the next pre-lab. Pay attention to the deadline so that you don't miss it. Lastly, make sure that you've selected this course on the course selection system. That's all about this lab. Good luck with your experiments.